Today, we are going to finally go to the back propagation. This is one of the for the propagation, for the feed diagram. You can say there are two inputs and there are two outputs. Then in the middle, layer 1, 2, 3, we also call those as a hidden layer. Those layers have some perceptrons, so we can say some nodes are there. Then each wire has weight value, like a scalar. Then error equation is still the same, 1/2 times sigma target value. This one is target minus the final output square. So you can also say final output is final output of the recent node times the final wire. So you can also rewrite as xi final times weight ii final. So this ii means one is input, first one is input, second one is output. Actually, input also has a level. Input level is 0 because this one has x sub 0. X sub 1 means input level is 1. So I represent the input level. So everything on this one, on the bottom is I is 0. Everything on the top is I is 1. If you have like a more perceptron that has I goes to 2. Then vertically, you can say they are layers. The direction of the forward feeding is left to right. Now, when we have a training set, we would like to make our error go to 0. So we would like to find our error as a minimum. Sometimes like a 0.01 is the goal, like a 1%. So depends on our goal, 0 or 0.1, 0.1 or 0.1, like whatever. We would like to minimize the error or meet the goal error. But if our first initial network is not working well, we can update this network by changing the weight values, because weight is the scale factor to change final output values. So what we are going to do is we are going to use the negative gradient. So goal error goes to the 0 or minimum. So that is the direction. Then by using this direction toward each weight, by calculating this one, we are going to improve each weight. So we are going to change it. Then we are going to train again and change again until we get the goal error value. So let's think about how to calculate the negative gradient first. So there are two types of negative gradient. If I show you the backpropagation diagram first, each weight is separate, independent. So you are supposed to calculate the partial negative gradient for respect to each weight. So there are like two shapes. One is input and output are the same, and only final one is going to the one, have only one wire at the final layer, layer 3 to the output layer. So you are going to calculate this one separately. So final gradient. Then another one is in the middle part. So middle part gradient, you can also find a pattern to calculate. So final is here, then middle part gradient can be like a generalized weight J to K to layer. So all those we can generalize. Some are missing here. And final one. So we can calculate two. First, let's calculate the final one. Looks easier. Arrow equation is still the same, 1/2 sigma. In this case, we have up to layer 3 and output layers, so we can say training target I minus y layer 3i. So this I represents input level or input. So you have two. T0 minus Y0 layer 3 or T1 minus Y1 layer 3. In this case, depends on the network. This one, we are going to just use a number for the specific case, then you can write the generalized later. Actually, generalization, we can use at the final layer. So let's calculate this one. We are going to do negative gradient, so negative partial with respect to final weight. So in this case, weight, input output are the same, 0, 0 or 1, 1. So input output same, JJ, layer 3, because final layer is 3. Then this is the error equation in this case. If you do the derivative, 2 goes out, then inside the 1, sigma is still there, then derivative of the in Ti minus Yi layer 3. So you can write down as a partial. Then you can think about this partial if you can simplify more. If you see here, target value is given at the beginning. So it's just a constant, not dependent on the weight. So when you rewrite this partial over T over W minus Y over W, Y over weight, then you can say this is constant, so derivative is 0. So you can write only Y sub I layer 3. Then if you see here negative outside and negative before Y, so you can cancel out. Now you can think about Y sub I3 is, you see the forward feeding diagram here? How to get Y1 layer 3 is X1 layer 3 times weight 1 to 1 layer 3. So instead of Y1 layer 3, you can write X1 layer 3 times weight 1, 1 layer 3. So we can use I for those things because there are two output, or you can have a multiple output. If you rewrite down here, then you can think about the situation. There are two things, but X1 and weight 1, 1 never related to X0 and weight 0, 0. So only when J value are equal to I value, they are dependent. Because of that, we can cancel out the sigma. Only when I are equal to J, we can find the partial. If I and J are not the same, we can say partial is 0 because they are independent. So you can simplify this one to only J case. So by using J here, you can cancel out the sigma. Then when you do the partial of this one, the product rule. Now, x is not dependent on weight, so when you do the partial x over w times w, that is 0. For this case, x is input, then they are not x1 layer 3 and weight 1 layer 3 are not dependent to each other. But when you have the same thing, weight jj layer 3 respect to weight jj layer 3, that is the same thing, so it is 1. So you can simplify as xj layer 3. So instead of the whole partial, you can just write xj layer 3. Then that is, if I show in the backpropagation network, you are going to build the backpropagation network by yourself. This wire's gradient vector. So this wire's gradient value, that means we can think about how to calculate to get this one by using this diagram, those two diagrams. For the feeding is already done. So if we make the new network, and actually we need only first part, Tj minus Yj layer 3. So you can put in the one new node here on the backpropagation network at E. This one's input level is 1. Layer can be output final layer. You are gonna have T1 minus Y1 layer 3 final layer, or T0 minus Y0 layer 3. Then by multiplying X, if I do this one, combining from the fourth feeding x1 layer 3, by multiplying those two values, you're gonna get wires, this circle wires, negative gradient.